General term of a sequence. The general term of a sequence, it is sometimes called nth term, is written as Tn, where Tn is the image of the element whose order is n, and can be found sometimes through the given terms of the sequence by realizing the relation between the value and the order of the term. The relation between the value and the order. Now we will take example to explain this. The general term of the sequence of even numbers 2, 4, 6, 8, and so on. What is the general term can be written for this sequence? The general term is Tn equals to n. There is a relation. There is a relation between the order and the value. What we mean by that? Here is the order is 1. It is the first term. So T1 equals 2 multiply 1. 2 multiply 1 equals 2. What is the order of the second term? It is of order 2. So we mean T2 equals 2 multiply 2 equals 4. When you want to calculate the fourth term, put n equals 4. So you will get T4 equals 2 multiply 4 equals 8, and so on. So the general term of this sequence is 2n. So you can determine any term of this sequence by using the general term. Another example for the general term. The general term of the sequence of odd numbers, it is 1, 3, 7. How you can deduce the order or the term of order 100, for example. T100, how you can calculate it? We must calculate it using the general term. So what is the general term of this sequence? The general term Tn equals 2n minus 1. So if required to write T100, just substitute n equals 100. So T100 equals 2 multiply 100. 200 minus 1, it will be 199. Okay. If you want to calculate T4, so substitute n equals 4. What you get? T4 equals 2 multiply 4 minus 1. 2 multiply 4 minus 1 equals 8 minus 1, which equals 7, and so on. So you can determine any term of this sequence using the general term. The general term of this sequence, negative 1 over 3, 1 over 4, negative 1 over 5, 1 over 6, and so on. If they require to find any term, T5, T4, T3, how you can determine it? We always use the general term. So what is the general term of this sequence? The general term is Tn equals negative 1 power n over n plus 2. Let us try it. If they required to find the T1, we know that T1 equals negative 1 over 3. But how you can deduce it? Using this formula. Just substitute n equals 1. So T1 equals negative 1 power 1 over 1 plus 2. 1 plus 2 equals 3. Negative 1 power 1 equals negative 1. What about T4? We know that T4 it's 1 over 6. But how can you calculate it using the general term? Just substitute n equals 4. So T4 equals negative 1 power 4. Negative 1 power 4 equals 1. and 4 plus 2 equals 6, and so on. Some sequence do not have a defined rule till now, such as the sequence of the prime numbers 2, 3, 5, 7, and so on. There is no rule like this to determine any term of this sequence. Example 2, write down the first 5 terms and the general term of the sequence Tn, which is defined as follows. Okay, the required here is to write the first 5 terms and then write the general term. Okay, we have T1 equals 2 and Tn plus 1 equals 2n, where n is greater than or equal 1. So this is given, and the required is to write the first 5 terms. So we substitute. This is a given, we write it. T1 equals 2 and Tn plus 1 equals 2n. We substitute n equals 1, 2, 3, 4, 5, and so on in this relation as follows. When you substitute n equals 1, what you get? So let n equals 1. Substitute n equals 1. 1 plus 1 equals 2. So we write T2. Substitute n equals 1. You will get 2 multiply T1. We write 2T1. Then T2 equals 2 multiply T1. From the given, T1 equals 2. So T2 equals 4. And we write 2 power 2. It's equal to power 2. Okay, what about the next term? We substitute we substitute n equals 2. When you substitute n equals 2, you will get T3. 2 plus 1 equals 3. So T3 equals 2 multiply T2. And we know that T2 equals 4. So it is easy to calculate T3 as follows. Let n equals 2. So T3 equals 2 T2. What is the value of T2? It is 4. 2 multiply 4 equals 8. And 8 equals 2 power 3. By substituting T2 equals 4. Let n equal 3 here. So 3 plus 1 equals 4. So substituting n equal 3, you will get T4. And T4 equals 2 multiply T3. 2 multiply T3. What is the value of T3? It is 8. So T4 equals 2 multiply 8 equals 16. Substitute n equals 4. You will get T5 equals 2 T4. So T5 equals 2 multiply 16. 16 is the value of T4, which equals 32. So the first 5 terms, we have T1 equals 2, we write it, and we deduce T2, it is 4, we write it. T3 equals 8, we write it, and 16 and 32. So this is the first 5 terms. So what is the relation between any term and its order? Don't forget, the order of first term is 1, the order of second term is 2, the order of third term is 3, and so on. All of this equals, here is 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5. So the nth term equals 2 power n, and this is the rule. So the general term of the sequence Tn is Tn equals 2 power n. When you want to express the sequence whose general term is Tn, you must write it between brackets. So this form express the sequence itself. So the sequence, how you write it? Sequence Tn. Or you can say the sequence whose general term is Tn. Okay, what is the general term itself? Tn equals 2 power n. When you want to deduce the next term will be T6. Just substitute n equals 6. T6 equals 2 power 6 and you calculate it. Try to solve 2. Write down the first 6 terms of the sequence Tn, where Tn plus 2 equals Tn plus 1 plus Tn, where n is greater than or equal 1 and T1 equals 2 and T2 equals 3. Solution. First we write the given T1 equals 2 and T2 equals 3. It's from the given. And we substitute n equals 1. Put n equals 1. You will get here 1 plus 2 equals 3. 1 plus 1 equals 2. And we have T1. So T3 equals T2 plus T1. What is the value of T2? From the given T2 equals 3. We substitute. T1 equals 2. So 3 plus 2 equals 5. Now put n equals 2. 2 plus 2 equals 4. 2 plus 1 equals 3. 2. So we'll get T2. The value of T3 is 5. The value of T2 is 3 from the given. So the result will be 8. Now put n equal 3. 3 plus 2 equals 5. 3 plus 1 equals 4. T3, it's T3. What's the value of T4? T4 equals 8 plus T3. And T3 equals 5. So 8 plus 5 equals 13. Now put n equals 4. So we have T6 equals 21. By the same way, you put n equal 4. So in this rule, 4 plus 2 equals 6. 4 plus 1 equals 5 plus T4. T5 equals, from the previous step, T5 equals 13. We write it. T4 equals 8. So 13 plus 8 equals 21. But we have T1 and T2. Now we have T3, T4, T5, T6. Then we write the first 6 terms. So the first 6 terms are 2 and 3, 5, 8, 13, and 21. So Tn equals 2, 3, 5, 8, and so on. And this is the required sequence. Increasing and decreasing sequence. Definition: the sequence Tn is called increasing if Tn plus 1 is greater than Tn. For example, T2 greater than T1, or T3 is greater than T2. So it is increasing sequence. Example: this sequence, -5, -1, 3, 7, 11, 15, and so on. This is increasing sequence. 3 is greater than negative 1. Negative 1 is greater than negative 5. 11 greater than 7. So always Tn plus 1 is greater than Tn. The sequence Tn is called decreasing if Tn plus 1 is less than Tn. Example 4, 2, 1. It is decreasing sequence. And we have constant sequence. What is the definition of the constant sequence? The constant sequence, the whole terms of the sequence are equal. Like this. Tn equals 3, 3, 3, or 2, 2, 2, and so on. This is a constant sequence. Tn plus 1 equals Tn plus 1 equals Tn. Always Tn plus 1 equals Tn. Example 3. Show which of the sequence Tn is increasing, decreasing, or otherwise. Otherwise not increasing, not decreasing. Let us try the first one. Solution. Tn equals 2n plus 3 and Tn plus 1. Substitute n equals n plus 1. What you get? 2 multiply n plus 1. Instead of n, we substitute n plus 1. Because we want to calculate Tn plus 1. So 2 multiply n plus 1 plus 3 equals 2n plus 5. 2 multiply n, 2n. 2 multiply 1. It is 2 plus 3 equals 5. So Tn equals 2n plus 3, and the next term Tn plus 1 equals 2n plus 5. Tn plus 1 minus 2n equals 2n plus 5 minus 2n plus 3 equals 2. 2n minus 2n equals 0, and 5 minus 3 equals 2. It is greater than 0. Positive number. So the difference between Tn plus 1 and the Tn is 2. It is a positive number. So Tn plus 1 is greater than Tn because the difference is positive 2. So when Tn plus 1 greater than Tn, so you can say, what you can say? We can say that the sequence is increasing. Tn plus 1 greater than Tn, then the sequence is increasing for all the values of n. B, Tn equals 1 over 3n minus 1. We write it. And we write Tn plus 1. Tn plus 1 equals, after you substitute n by n plus 1, it will be 1 over 3n plus 1 minus 1. 3n, we write it, 3 by 1 equals 3, minus 1 equals 2. So Tn plus 1 equals 1 over 3 plus 2. Tn plus 1 minus Tn, after you calculate it, of course, we write the two terms here. Tn plus 1 minus Tn, it is the common denominator. What you get? 3 minus 3, 3n minus 3n equals 0. Negative 1 minus 2 equals negative 3 over 3n plus 2 multiply 3n minus 1. This value is always positive because n always positive. N, it is the order. always positive. So this product is positive and the numerator is negative. So the result of this fraction always negative for every value to n less than 0. So Tn plus 1 is less than Tn, so the sequence is decreasing. See, Tn equals negative 1 power n over 2n plus 4. And we must write Tn plus 1. Tn plus 1 substituting n equals n plus 1. We will get negative 1 power n plus 1 over 2 multiply n plus 1 plus 4. Now we calculate Tn plus 1 minus Tn. Tn plus 1 minus Tn, we will get rid of 4, because 4 minus 4 equals 0. So the result will be negative 1 power n plus 1 over 2 multiply n plus 1 minus negative 1 power n over 2n. Note that negative minus 1 power n over 2n equals positive negative 1 multiply negative 1 power n over 2n. Again, negative 1 power n equals positive negative 1. Instead of negative, we write negative 1 multiply negative 1 power n, negative 1 power n all over 2n. So negative 1 power n, it will be negative 1 power n plus 1. What is the power of negative 1? It is 1 plus n. So the result of this multiplication will be negative 1 power n plus 1 all over 2n. So from the beginning, Tn plus 1 minus Tn equals the first fraction plus negative 1 power n plus 1 over 2n. Now we can take negative 1 power n plus 1 as a common factor. So the result will be negative 1 power n plus 1. We have 1 and 1 over 2n plus 1 plus 2n. And now it's easy to add these two fractions by writing the common denominator. What is the common denominator of these two fractions? 2n multiply n plus 1. And the numerator will be, how you add this? 2n multiply n plus 1 divide 2 n plus 1, the result will be n. n multiply 1 equals n. 2n multiply n plus 1 divide 2n, the result will be n plus 1. n plus 1 multiply 1 equals n plus 1. So we have negative 1 power n plus 1. n plus n, it's 2n plus 1 over the same denominator. And this result depends on the first term here. This fraction is always positive for all the values of n. This fraction is always positive. What about negative 1 power n plus 1? When you put n equal 1 or any odd number, this term will be positive. Again, when you put n equals 1 or any odd number, then negative 1 power n plus 1 always positive. Example, put n equal 1. 1 plus 1 equals 2. Negative 1 power 2, it's positive. Put in any other odd number, like 5. 5 plus 1 equals 6. Negative 1 all power 6, it's positive. When you substitute n even number, any even number like 2 or 4, put n equal 2. 2 plus 1 equals 3. Negative 1 power 3, it is negative. Negative 1. So the expression is positive when n is an odd number, and the negative when n is an even number. So the sequence is neither increasing nor decreasing. I hope you got it. Try to solve 3. Show which of the sequence Tn is increasing, decreasing, or otherwise. A, B, C. The same steps. Solution. With respect to A, we calculate Tn plus 1 minus Tn. Tn plus 1 will be 2 over n plus 1 minus 3 minus Tn. So it will be negative 2 over n plus 3. And you calculate it, you will get 2n minus 2n minus 2 over n multiply n plus 1. Now you can cancel 2n minus 2n equals 0. So the result will be negative 2 over n multiply n plus 1, and it is always negative. This fraction is always negative less than 0. So what you can say about this sequence? The sequence Tn is always decreasing. It's decreasing because Tn plus 1 is less than Tn, as the result is negative. What about B? Tn plus 1 minus Tn equals half power n plus 1 minus half power n, and the result will be less than 0. Less than 0, it means decreasing. The sequence is decreasing. Third one, Tn. Now we can get it directly substituting n equals 1, 2, 3, and so on. So T1 equals negative 2 power 1. It is negative 2. Put n equals 2. You will get negative 2 all power 2. It's 4. Put n equals 3. You will get negative 8. So it is negative, positive, negative, positive, negative, and so on. So the sequence Tn is neither decreasing nor increasing. And this is the end of the lesson.